question 1, parts A and B, we're asked about the behaviors of the supply and demand parties towards tax and subsidies. In part A, it says when the government subsidizes an activity, resources such as labor, machines, and bank lending will tend to gravitate toward the activity that's subsidized and will tend to gravitate away from this activity that's not subsidized. Subsidies result in the government paying the supplier more money, so they would want to gravitate towards the activity that's subsidized. Inversely, in part B, when the government taxes an activity, resources such as labor, machines, and bank lending will tend to gravitate away from the activity that's taxed and will tend to gravitate towards activity that's not taxed, as taxes would be the detriment of the suppliers and buyers, as the suppliers would have to raise the price more to make up more money. In question 2, we're given a situation. Junk food, it says junk food has often been criticized for being unhealthy and too cheap, enticing the poor to adopt unhealthy lifestyles. Suppose that a state of occurrences imposes a tax on junk food. Well, what needs to be true for the tax to actually deter people from eating junk food? Should junk food demand be elastic or should it be inelastic? When a curve is elastic, it means that there's substitutes. So if a demand curve was elastic, that means there's more demand substitutes. If the supply curve was elastic, that means that the workers could move to a market. There are many markets for the workers to move to. So in this case, the tax would deter large trades only when the demand curve is elastic, as the people would have a reason to move to different markets such as healthy foods, which will help them. So in part B, we are asked if the Oakland's government wants to strongly discourage people from eating junk food, when we'll need to set a higher tax rate, when junk food demands elastic or when it's inelastic. What we learned in Parasol is that the curve with the that's more elastic would have to pay less tax. So though if the consumers though the demand curve was inelastic, they would pay more. It would hurt consumers without any societal benefits, since they won't be able to substitute healthy foods. So in this case, the government should set a higher tax rate when junk food is elastic, because consumers would be able to substitute healthy foods. They wouldn't lose money. So in part C, we're asked, well, hold up a minute, the supply size matters as well. If junk food is highly elastic, perhaps it's not that hard to start selling salads with low-fat dressing instead of mayonnaise. Does that mean that a junk food tax would have a bigger effect than if supply were inelastic, or is it the other way around? What we said was, if the supply is highly elastic, the supply side would tend to escape the tax burden more easily. That means that they wouldn't have to pay. They would pay less than the buyers. The junk food tax would have a small impact on the suppliers in that case, but that also means the demanders would get hit harder by the tax. In question 2, part B, we are asked to combine stories now. If the government is hoping that a small tax could actually discourage a lot of junk food purchases, it should hope for option 2, elastic supply and elastic demand. In this case, they wouldn't lose so much money.
In question 3, we're looking at taxes graphically on the supply and demand curves. We're first asked to find the total revenue raised by the tax, which, when looking at the graph here, is the rectangular area to the left of the tax wedge bound by the consumer-producer surplus. So the revenue is 500 baskets times the tax of $1, which it equates to $500. We're then asked to find the total deadweight loss from the tax, which is calculated by finding the area of the triangle bound by the tax wedge and the supply and demand curves. So here we multiply the difference between 700 and 500 baskets, 200, by the tax of $1, and then divide it by 2 to get the total deadweight loss of $100. So moving on to question 4, we're looking at the graphs more in depth using a tax of $2 for our calculations. When we put that $2 tax wedge into the curves, we find the top point of the wedge, the amount the buyers pay, is $7, and the bottom point of the wedge, the amount suppliers receive, is $5. The revenue, which is again the rectangle to the left of the wedge, is $2 times 4, or $8 here. And the deadweight loss, again the triangle to the right of the wedge, is approximately $2 times 1.5 divided by 2, or about $1.50. And I say approximately because we're assuming that the equilibrium quantity is about 5. And for part B, we're looking at a $5 subsidy rather than a tax. Here, buyers would pay $2 and the suppliers would receive $7. And the total cost to the government, here the rectangle that spans from the price axis to the wedge, is $9 times 5, or $45 in total. Of course, that will be paid by taxpayers' dollars. The deadweight loss, the triangle to the right of the equilibrium and to the left of the wedge, is $5 times about 3.5, and divided by 2, which is approximately $8.75.
In question 5, we're asked to consider the phenomenon in which the government tries to collect more income tax from wealthier people, yet it's harder to collect said tax from them than from poorer people. In question A, since the income tax is progressive, meaning it taxes higher incomes at higher rates, we are trying to figure out why it's difficult to collect tax revenue from a wealthy individual as opposed to a poorer individual. The supply for labor is relatively inelastic in general, but for wealthy people, it's more elastic because they have more alternatives, more opportunities than poorer people to find different careers and replace their sources of income with fringe benefits, etc. So if the government tried to use luxury taxes to tax the rich, that would most likely hurt the sellers more because luxurious goods have high elasticities of demand since they're not by any means necessary. So if the government decides to tax jewelry, it'll hurt the sellers because people will just buy something else or forego buying jewelry. But the sellers don't have many options to substitute the thing that they specialize in creating. The next part talks about the estate tax, asks about its effectiveness from the example in the beginning of the chapter. So wealthy individuals have an elastic demand for leaving an inheritance because they're able to adjust the state in which they die, which has different laws on the estate tax. So they move, for example, from New Jersey to Florida, and that greatly reduces the amount of money that's taken out of their endowment that they leave to their children. They can also exploit seasonal changes and changes in the business cycle to give themselves the maximum benefit. So that's why the estate tax has fairly inelastic demand. Question 6 shows a diagram of a tax, and we need to calculate deadweight loss with we're interpreting the real meaning of the base and the height. The base, which is actually on the y-axis because it's kind of flipped in economics, is the value of the tax. The height is the quantity exchange equilibrium minus quantity exchange at post-tax price. Alright, general rules about deadweight loss. The larger the wedge is, the more deadweight loss is generated by that tax. So the height and thus the deadweight loss will get larger if the demand curve or the supply curve are more elastic. As the demand and supply curve becomes more horizontal, it increases the area mathematically. Without having a diagram, can you answer the preceding questions? Okay, the base of a triangle is equal to the value of the subsidy. Height is the difference in quantity exchanged at the subsidized price minus quantity exchange at the equilibrium price. So much like a tax, if the subsidy is larger, there's a larger deadweight loss, but for the opposite reason of a tax. It's not because the trades that could be beneficial aren't occurring, it's because non-beneficial waste of resources is happening more often. Right, the more elastic a supply or demand curve is, the greater the deadweight loss.
Now let's look at question 7, where we are given a situation as such. The state government has decided to tax donuts, and we are given 3 options. And for each of those options, we want to calculate the total revenue as well as the total deadweight loss resulting from that tax. So for the revenue, for the first option, we have $50,000 of revenue. For the second option, we also have $50,000, but for the third option, it's significantly higher, which was $75,000. But for the deadweight loss, we also see huge differences between the 3. So the first option, the 20-cent option, we are losing $5,000. For the second option, we're losing $12,500. And for the third option, we have the highest, which was $37,500. So if the goal of our state government is simply to raise the most tax, we would, of course, choose the 50-cent tax because it generates the highest revenue, $75,000 among the 3 options. But if the goal of our state government is to raise tax revenue in the most efficient manner, which means we want to minimize the deadweight loss, we would want to use the 20-cent tax because it has the lowest deadweight loss among the 3 options, equating to only 10% of the revenue. Last part of this question, we said another goal might be to discourage the purchase of donuts for health reasons, just like what we've seen in question 4 of this lab. Similar to taxes on cigarettes, we want to deter people from purchasing unhealthy foods, and that is why we might want to raise taxes. Going on to question 8, for this question we answered that for the sellers to not pay any tax, i.e. not take any of the tax burden, the seller must have infinite substitutes, or the supply curve must be perfectly elastic, or the buyers must have no other choices but to buy from the seller. For the subsidies to benefit the sellers only, they must have a total disadvantage when it comes to tax, meaning they will bear all the tax burden, and the seller must have no substitutes, or the buyers have other choices, making the demand very elastic.